Our task is to write the truth table of the logical statement, the negation of if P, then Q. We can see here that the logical operator for conditional is inside the grouping symbol, while the negation is outside. We need to look into these considerations as we plan for our truth table. The truth table will have the number of rows determined by this formula, 2 to the power of n, where n is the number of propositions identified on our statement. Since we only have P and Q propositions, we have 2 propositions, hence this will become 2 squared, which will give us 4 rows. In short, in our truth table, excluding the header, we need to add 4 rows. Our truth table will have P and Q propositions for the first 2 columns. So we will have here the columns, and we'll be adding, as mentioned, 4 rows. We'll have 1, 2, 3, and 4 here. This is identified with the formula earlier. If you would like to add this as one of your rows, no need to worry, it doesn't count with the formula. That's just for your header. So in the first 2 columns, we just need to place the appropriate truth values for each proposition. Here, for our first column, we'll be placing here true and true for the first 2 rows, and this will be paired by, for our Q proposition, you have true and false. To complete the first row, we'll have here false, and for our second column, you will have here true and false. So we can see here all the combinations for the truth value of each proposition being identified here. Now, look into our logical statement. As mentioned, the conditional logical operator is inside the grouping symbol. Hence, we will be starting with that here. We will be adding the column for the conditional statement if P, then Q. By the way, if you were able to memorize the truth tables for logical statements or different logical statements which it includes the conditional statement if P then Q, then it's very easy for you to take the truth table of this logical statement, the negation of that, because you simply need to reverse the truth values for each of the rows identified. But since here, for the purpose of the discussion, let me illustrate or re-illustrate the truth table for the conditional statement and then going forward for its negation. So we have here 4 rows as identified. So here are the possibilities for the truth table for a conditional statement. Number 1, the conditional statement is true if both propositions P and Q are true. And number 2, regardless of whatever is the truth value of our Q, the conclusion statement on our conditional logical statement, as long as the hypothesis or the P proposition is false, automatically the entire conditional statement is true. Here are the details. For the first row, we have true and true for our P and Q propositions. Both propositions are true, so the conditional statement is true. For the second row, the first proposition P is true. However, the conclusion, the Q proposition or proposition Q is false automatically. This makes our conditional statement false. Because as mentioned, we need both, for the first condition, we need both statements to be true for our conditional statement to be true. Now here comes the third and fourth row. We can see that our proposition P are both false. Now, regardless of whether our Q is true or false, automatically this fits the second condition. The conditional statement should be true. Now, there might be a separate video discussing this further, but this is the idea for the truth table of the logical statement conditional. Now, we are going to finish this by adding the negation of this result. As mentioned, if you're able to memorize the truth value for the logical statement for conditional, automatically you need to reverse it to get the negation. So that's what we're going to do here as well. So we'll be adding another column, but this is for the negation of if P, then Q. So negation is the reversal of the truth value for whatever proposition or results of logical statements. So the first here is true, its reverse is false. This is false, so we'll have here true. This is true, this should be false. And this is also true, this should also be false. This completes now the truth table for the logical statement, the negation of if P, then Q. Don't forget to like and share our videos, leave a comment, and reasonably subscribe to our channel.